Acidizing is not a mechanical process. It is a chemical system under limited control. Now define the core problem. Acid reacts with whatever it contacts, at whatever rate conditions allow. You cannot direct acid. You can only influence its environment. Now define the governing principle. Acid does not know where to react. You must control where and how it reacts. Now define why this creates risk. Reaction occurs at poor scale. Controlled by temperature, concentration, contact time, and transport. Small design errors create large differences in outcome. Now define system failure structure. All acidizing failures originate from 4 sources: reaction, compatibility, placement, execution. Now define logic. Reaction failure. Acid reacts too early, too fast, or not enough. Compatibility failure. Acid creates new damage during reaction. Placement failure. Acid does not reach the damage zone. Operational failure. Design is not delivered as intended. Now define engineering reality. Acidizing can improve permeability or reduce it. Final rule. Acid does exactly what physics and chemistry allow. Success depends on how well you control it. Acidizing is not inherently successful. It is inherently unstable. Now define the problem. The same acid that removes damage can create new damage. Outcome depends on where acid goes, how fast it reacts, and what it produces. At the poor scale, reaction follows physics, not design intent. Now define consequence. Small errors in design create large deviations in outcome. A slight change in concentration, or rate, or volume, can shift the system from improvement to damage creation. Now define engineering reality. Zero improvement is not the worst outcome. Negative improvement is possible. Permeability can decrease after treatment. Skin can increase. Now define system structure. All acidizing failures fall into 4 categories: reaction, compatibility, placement, execution. Now define logic of each. Reaction failure. Reaction occurs in the wrong place or at the wrong rate. Compatibility failure. Reaction produces solids or unstable fluids that block the formation. Placement failure. Acid is correctly designed but reaches the wrong zones. Operational failure. Acid system is not delivered as designed. Now define system rule. Every acidizing failure must be mapped to one of these 4 categories. Final condition. If you do not identify the category, you will repeat the failure. Reaction failure is not random. It is controlled by one variable: injection rate relative to reaction rate. Now define the system. Acid transport competes with acid reaction. If reaction is faster than transport, acid is consumed near the wellbore. If transport dominates, acid penetrates deeper into the formation. Now define the 3 failure modes. First, premature acid spending. Reaction rate is too high. Acid is consumed immediately. No penetration occurs. Only surface dissolution. Now define outcome. Damage zone is never reached. Treatment is shallow. Now define rule. If acid reacts before it travels, it cannot stimulate. Second, excessive reaction rate. Reaction occurs everywhere, without structure. No dominant flow paths form. No efficient wormholes develop. Now define outcome. Irregular dissolution. High acid consumption. Low efficiency. Now define rule. If reaction is uncontrolled, acid is wasted. Third, incomplete reaction. Acid volume is insufficient, or coverage is incomplete. Reaction stops before damage is removed. Now define outcome. Partial improvement. Residual skin remains. Now define rule. If acid supply is insufficient, treatment remains incomplete. Now define the governing principle. Effective acidizing requires a balance between transport and reaction. This creates the optimal regime: wormholing. Acid penetrates while reacting, forming conductive channels. Now define engineering control. You do not control reaction directly. You control it through injection rate, acid concentration, temperature effects. Final rule. Reaction must occur at the right place and at the right rate. If not, acid either reacts too early, too inefficiently, or not enough. Reaction failure reduces effectiveness. Compatibility failure creates damage. Now define the problem. Acid does not disappear after reaction. It produces new chemical products. Those products must remain soluble. If not, they block the formation. Now define first mechanism. Precipitation. Reaction produces dissolved ions. As pH increases, these ions become solids. Iron forms iron hydroxide. Calcium and fluoride form calcium fluoride. These solids deposit inside pores. Now define outcome. Permeability decreases. Skin increases after treatment. Now define rule. If reaction products are not controlled, acid creates new blockage. Now second mechanism. Emulsion formation. Acid interacts with hydrocarbons. Unstable mixtures form highly viscous emulsions. These emulsions move slowly. They accumulate near the wellbore. Now define outcome. Flow resistance increases. Production declines after initial response. Now define rule. If fluid compatibility is not ensured, mobility is lost. Now third mechanism. Clay swelling and migration. Formation contains sensitive clays. Water chemistry changes during treatment. Clay expands or detaches. Detached particles migrate and block pore throats. Now define outcome. Permeability is reduced after treatment. Now define rule. If mineral behavior is not controlled, formation structure is destabilized. Now define system insight. Compatibility failure occurs during the treatment, not after. Now define consequence. The treatment itself creates damage. Final rule. Acid must be compatible with rock, fluids, and minerals. If not, the treatment becomes the source of damage. Reaction defines what acid can do. Placement defines where it actually acts. Acid only works where it goes. Now define the system. Fluid follows the path of least resistance. High permeability zones accept most of the flow. Damaged zones usually have lower permeability. Now define consequence. Acid naturally avoids the zones that need treatment. Now define first failure. Non-uniform distribution. High permeability zones dominate flow. Acid enters these zones repeatedly. Damaged intervals receive little or no acid. Now define outcome. Partial treatment. Residual damage remains. Now define rule. If flow is not balanced, coverage is incomplete. Second failure. Channeling. Acid finds a limited number of flow paths. Through fractures or high permeability streaks. These paths are overtreated. Surrounding rock remains untouched. Now define outcome. Localized improvement only. Most of the reservoir is unchanged. Now define rule. If flow concentrates, treatment becomes localized. Third failure. Incorrect placement method. Acid is injected without control. No zonal isolation. No targeted delivery. Acid flows wherever pressure allows. Now define outcome. Clean zones receive acid. Damaged zones are bypassed. Now define rule. If placement is uncontrolled, effort is wasted. Now define engineering insight. Reaction design assumes uniform contact. Flow behavior guarantees non-uniform contact. This is the core contradiction. Now define control. Placement must be forced, not assumed. Mechanical isolation. Flow diversion. Targeted delivery. These are not optional. Final rule. Placement failure negates all other design work. If acid does not touch the damage, the treatment does not exist. Up to this point, you controlled reaction, compatibility, and placement. Now define the next risk. Even with correct design, failure still occurs during execution and after treatment. First system. Operational failure. Design is correct. Execution is not. First mechanism. Incorrect fluid mixing. Acid composition changes. Additives are missing or incorrect. Outcome. Reaction becomes unpredictable. Rule. If the fluid is wrong, reaction control is lost. Second mechanism. Injection rate error. Rate defines the reaction regime. Too low. Reaction occurs near the wellbore. No penetration. Too high. Unstable flow. Fracturing may occur. Outcome. Treatment deviates from design. Rule. If rate is not controlled, reaction cannot be controlled. Third mechanism, pressure instability. Flow conditions fluctuate during pumping. Outcome, uneven distribution and poor contact. Rule, unstable execution creates unstable placement. Second system, secondary damage. Damage occurs after pumping. First mechanism, reprecipitation. As pH increases, dissolved products become solids. Outcome, new blockage forms after treatment. Second mechanism, fines migration. Acid weakens grain bonding. Particles detach and move. Outcome, pore throats are blocked. Third mechanism, residual fluids. Spent acid and chemicals remain in the pore space. Outcome, continued blockage after treatment. System insight. The treatment does not end when pumping stops. Flowback is part of the treatment. Final integration. Execution controls what is delivered. Flowback controls what remains. Final principle. A successful acid job is not defined at pump off. It is defined after cleanup. At this stage, stop focusing on the treatment. Focus on the response. Production behavior is the only reliable indicator of what actually happened in the formation. Now define failure mapping. Each response pattern corresponds to a specific failure mechanism. First case, no improvement. Production and skin remain unchanged. The acid had no effective impact. 2 explanations. Acid reacted too early near the wellbore. Acid never reached the damage zone. Interpretation. Reaction failure or placement failure. Rule. If nothing changes, the problem was never contacted. Second case, partial improvement. Production increases, but not to the expected level. The acid interacted with the formation, but not completely. Cause, insufficient acid volume. Incomplete coverage. Rule. If improvement is limited, the treatment was incomplete. Third case, early decline. Production improves, then drops quickly. The treatment worked initially, but conditions changed after pumping. Mechanism. Reaction products precipitate and block flow paths. Cause, secondary damage. Rule. If performance declines after success, damage was created after treatment. Fourth case, irregular response. Production does not match design. Pressure behavior may be unstable. Cause, fluid incompatibility. Unstable execution. Rule. If results are inconsistent, the system was not controlled. Core principle. Failure patterns are not random. They are diagnostic signals. Final rule. Do not redesign the treatment until the failure pattern is clearly identified. Everything in this lesson reduces to 6 engineering rules. First, all acidizing failures originate from 4 sources: reaction, compatibility, placement, execution. Every failure belongs to one of these. If you cannot classify it, you cannot correct it. Second, reaction controls penetration. If reaction is too fast, acid is consumed at the wellbore. This creates phase dissolution, not wormholes. Outcome: shallow penetration, low efficiency. Rule. Control injection rate to achieve the correct reaction regime. Third, compatibility determines whether damage is created. Acid produces secondary products. If unstable, they form solids, emulsions, or fines. Outcome: permeability declines after treatment. Rule. Verify chemical compatibility before pumping. Fourth, placement controls effectiveness. Acid only works where it goes. Flow is naturally uneven. High permeability zones dominate. Outcome: damaged zones remain untreated. Rule. Force distribution. Never rely on natural flow. Fifth, execution determines consistency. Design defines intent. Execution defines reality. Rate, pressure, and fluid quality control the result. Outcome: unpredictable and inconsistent performance. Rule. Control the job in real time. Sixth, secondary damage defines long-term performance. Even a successful treatment can fail after pumping. Precipitation, fines, and residual fluids block flow. Outcome: production declines after initial gain. Rule. Flowback is part of the treatment. Final integration. Reaction controls where acid acts. Compatibility controls what it produces. Placement controls where it reaches. Execution controls delivery. Secondary damage controls duration. Final principle. Do not evaluate at pump off. Evaluate after cleanup and sustained production. This lesson is not about acidizing. It is about control. Acid does not follow instructions. It follows physics and chemistry. Your role is not to apply acid. Your role is to control where it acts, how it reacts, and what it leaves behind. If you understand failure, you control the outcome. If you ignore failure, you repeat it. Final principle. Control reaction. Ensure compatibility. Control placement. Control execution. Do that, and acidizing becomes predictable.